ZImage has taken the lid off its base model. The hype has been massive, but the reality is more grounded. It isn't a revolution, but a refinement. Today, we find out if that's enough. The Turbo was made from ZImage base with reinforced learning, so Turbo is more visually attractive than ZImage base. However, the base model is more flexible and diverse, allowing different CFG values. You can also use negative prompts, and the model is easier to train for fine-tunes than LoRa's. Today, we're gauging the ZImage base against the Turbo model to see where that extra flexibility really lies. And if you stay tuned, I'll show you how to leverage GGUF quantized versions to run ZImage on low VRAM GPUs. In ComfyUI, choose the ZImage base template. Download the models that are needed to run the workflow. In the notes you have the links and the folders where to install the models. The workflow is rather straightforward. In Step 1, load the diffusion, clip, and V models. Step 2 defines the size of the image, and in Step 3 we have the prompt. In ZImage base we can add a negative prompt. In the case sampler, the number of steps has to be between 30 and 50, and the CFG between 3 and 5. The template settings work well, but let's first benchmark them against ZImage Turbo to see what the base model can really do. Let's open the ZImage Turbo template and see if we can spot differences. If you do not have the Turbo model, download it. This template has several options and it is in subgraphs, but let's unpack to understand the image generation workflow. If you look closely, the workflow of Turbo is essentially the same as ZImage base. Loading models, latent size, prompting and sampling. The diffusion models are different, so the number of steps and CFG need to be set differently. And ZImage Turbo does not use negative prompt. Let's set up our comparison. By duplicating the model routing, sampling, and decoding nodes, we can run both models simultaneously and get a clear look at those results side by side. We will concatenate the resulting images of each case sampler to compare them. For the parallel workflow, select the Turbo model in the diffusion loader, and in the case sampler set the number of steps to 4 and CFG to 1. To really have a side-by-side comparison, we have to use the same seed in both workflows. We do that with a primitive integer node connected to the seed of both case samplers. Run the workflow and check the output. Turbo seems to lean into a higher contrast, brighter look. Whether that's better quality is up for debate. However, one thing is certain: the base model seems to offer more variety in its generations. To see the difference more clearly, let's simplify our positive prompt. I'll strip back the specific physical descriptions, clothing details, and background elements to see if base really has more diversity in the generated images. Let's run again and see the results. In the Turbo version, the couple looks remarkably similar. The base model, however, generates distinct people for every seed. Now, let's test how they handle a change in the negative prompt. We'll try to filter out the white shirts and curly hair to see which model actually listens. Testing across different seeds, it's clear the Turbo model ignores the negative prompt entirely. In contrast, the ZImage base is highly responsive. The shirts are no longer white, and we've successfully filtered out curly hair as requested. Now, let's test the CFG influence on the base model. You'll notice that with more complex, descriptive prompts, the actual impact of the CFG slider is subtle. Looking at the results, increasing the CFG mostly just cranks up the saturation, making the scene appear darker. Beyond that, we're only seeing very subtle changes to the actual details. If we try with a more ambiguous prompt, the effect is more clear. A painting of Van Gogh can be a paint where the subject is Van Gogh, or a paint that could have been made by him. Let's see what happens. With some seeds, we see only the increase in saturation with CFG. But with others, different CFG end in different compositions. And the last run shows a clear impact of CFG in the image structure, from a general Van Gogh aesthetic into a blend of a self-portrait with starry night. Now let's experiment with a negative prompt to neutralize the Van Gogh style. We're looking to keep some reminiscence of Van Gogh, while minimizing the typical brushstrokes, testing how sensitive the visuals are to higher and lower CFG values. Let's also change the subject of the image and specify we want a dog. While layout and subject remain, notice how higher CFG values pull the model further from Van Gogh's characteristic textures. The last example is more clear. At low CFG values, the style remains despite the negative prompt. However, high CFG forces the model to break away from the aesthetic. And to finish, let's look at the quantized models for Z image. Quantized models reduce the numerical precision of the model, so they fit with low VRAM GPUs. They minimize the quality loss, but it is still challenging to select the version that fits your hardware's limits without sacrificing quality. You'll also find quants for the clip, which makes everything look very complex. But it's actually quite simple to set up. I've put the links for the models in the description. Now let's jump into ComfyUI and I'll show you how to plug them in. To use GGUF models, you'll need a custom loader. I recommend ComfyUI-GGUF by City96, but other options exist. Using them is simple, just add a unet loader GGUF node. Then replace the load diffusion model node with it. The unet loader will recognize the GGUF models you have in the diffusion models folder. Just select the one you want to use. As models evolve, clip files are getting massive. If you still need to save more VRAM, you can swap the regular clip loader for the clip loader GGUF node, and use a quantized version instead. Place your clip GGUF in the text encoder folder. Remember to select the specific model type in the loader, otherwise the workflow will not work. Lumina 2 is required for ZImage, both turbo and base. The diffusion and clip GGUF models work independently, so you do not need to use them in combination. Only if you want to. Here, we can see the effect of the Q8 versions of the quantized models. Generally, we want to take advantage of the compression of the diffusion model, so let's check how they compare. First, we are going to compare the BF16 version of the model with the FP8 version and the Q8 quantized model. Q8 and FP8 are half the precision size of FP16. However, their quality and speed are not the same. Here results are similar. The FP8 version is a little bit more different than the image from the Q8 quant. However, in this example the difference is clear. Q8 holds close to BF16, but FP8 introduces a significant change, switching the gender of one person in the portrait. On the other hand, the FP8 model is faster than the BF16 and the Q8 quant. Running Q8 gives you similar output as with the BF16 model, with half VRAM. But for those who need to go lower, you've got a lot of choices. Let's dive into the comparisons and see how much quality we actually lose as we drop down the quantization scale. Q8 and Q6 seem to be still rather similar and of good quality. With Q5 we can start noticing differences, depending on the seed we have. Q4 and Q3 may still deliver acceptable results, but we can observe a more washed-out AI effect. Finally, the Q2 quant is really noisy and not good. There are also different quantization methods. Let's see and compare for the Q5 quant. The composition of the images of the M and S quants are almost identical. Between the 0 and 1 versions, I've noticed the 1 quant looks better. The 0 can look a little washed out. My advice? Run a few tests yourself and stick with the one that looks best to your eye. And that's all for today. Thanks for watching. Bye.